Alright, here's my second attempt at making a YouTube video. This one deals with the determination of the empirical formula and the molecular formula. Empirical formula is nothing more than a simplest whole number ratio that describes the number of atoms of a particular element in a compound. And this one is determined through experimental elemental analysis, in which the masses of each element that is formed when you decompose or react that particular compound, and one method of doing that is through combustion analysis, or determination of the percent composition of a particular element in a compound. So how do we find an empirical formula? Here's the general four-step rule. First, assume you've got 100 grams of the compound, if given percentages, and then convert those percentages to masses. You can skip this step if you've already been given the masses of each of the elements that's in the compound. Second, you convert those masses to moles, convert grams to moles, using the molar mass. Third, once you get the number of moles of each element, you divide the number of moles of each element by the one that has the smallest number of moles. And if the result is within about 1/10 of a whole number, you can round that to a whole number. If they're not whole numbers, you multiply all of the ratios, the mole ratios, by some factor to make them a whole number. So, for instance, if there's a ratio that is 0.5, you would multiply all of them by 2. If there's a ratio of 0.33 or 0.67, multiply all of the ratios by 3. Or if you've got a 0.25 or 0.75, multiply everything by 4. And finally, the result of that is the empirical formula. So let's start out by trying to determine the empirical formula of ascorbic acid, which is vitamin C, given some percentage of biomass of each particular element in that compound. So elemental analysis indicates that there's 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen. So first step, assume you've got 100 grams. So 40.92% of 100 grams is 40.92 grams of carbon, and 4.58% hydrogen would equate to 4.58 grams of hydrogen, and 54.50% oxygen would be 54.50% 54.50 grams of oxygen. And then convert to moles using molar mass, and we know that 1 mole of carbon is 12.01 grams, and 1 mole of hydrogen is 1.01 grams, and 1 mole of oxygen is 16.00 grams. And when you calculate these, you hopefully will come up with something like 3.41 mole of carbon, 4.35 mole of hydrogen, and 3.41 mole of oxygen. So finally, you divide by the smallest, and the smallest in this case is 3.41, so divide both by the smallest, and you get 1. You get 1.33, and you get 1. And so this is your rough ratios. And remember, if you found something with a with a 0.33 decimal, we multiply all of the moles in this mole ratio by a factor of 3. And you come up with, for carbon, you would get C3, hydrogen H4, and oxygen 3. So this gives an empirical formula of C3H4O3 as our empirical formula. Now, how do we go from there to get the molecular formula? And what is the molecular formula? Well, the molecular formula is a multiple of the empirical formula. And what it does is it actually presents to you the actual number of atoms of each element in a molecule or a compound. And to determine the molecular formula, we need to know the empirical formula and the molar mass of the compound. So, if we take the molar mass of the molecular formula, something that is usually determined through experiment, and we take the mass of the empirical formula, so the empirical formula mass, we divide those two, we get this multiplying factor. And that multiplying factor is something that we multiply the entire empirical formula by to get the molecular formula. So, we recently determined that the empirical formula of ascorbic acid is C3H4O3, and its molar mass was determined to be 176 grams per mole. So there's a value that's given. What is the molecular formula? So if you take the mass of 3 carbons, 4 hydrogen, 3 oxygen, and you sum those up, you come up with something like 88 grams for the empirical mass. And we're going to take the molar mass, 176 grams, divided by 88, and that gives you 2, this multiplying factor. So what that means is the molecular formula is equal to 2 times the empirical formula. And if our empirical formula was C3H4O3, then our molecular formula is going to be C6H8O3. Alright, one more practice. Here we've got during excessive physical activity, lactic acid, determined to have a molar mass of 90.08 grams per mole. This compound forms, elemental analysis shows that the compound is 40% by carbon, 6.71% by mass hydrogen, and 53.3% oxygen. So determine a molecular formula of lactic acid. This might be a good place to pause, give it a shot, and then resume here in just a second. The answer I'll put up here very briefly, and starting with 40.0 grams of carbon, 6.71 grams of hydrogen, and 53.3 grams of oxygen. That yields 3.33 mole of carbon, 6.6 mole of hydrogen, and 3.33 mole of oxygen. Gives us a ratio, when you divide by the lowest, of 1 to 1. So our empirical formula is equal to CH2O. That empirical formula has a mass equal to 30 grams per mole. If we take the molar mass, 90 divided by 30 equals 3. That means that the molecular formula is equal to 3 times the empirical formula, and that should give us C3H6O3 as the correct molecular formula. Hope this helps.